Assalamualaikum warahmatullahi wabarakatuh and good morning everyone. So today we will continue our lesson on chapter 2, which is the introduction to microcontroller. Alright, so we continue our lesson with the programming of Atmega 328, right? So for Atmega 328, there are several methods for you to program the chip. Okay, so the first method is to use self-programming using any physical link. All right, so program through any interface, for example SPI or TWI. Okay, and then for this type of programming, it is 100% secure encrypted remote updates. Okay, so for self-programming using any physical link, the program with the help of resident bootloader. So the bootloader must be pre-programmed in the boot flash section. Okay, so the first type of programming is the one that you can see inside Arduino. So inside Arduino, the bootloader is already pre-programmed, and then you can do self-programming by using your USB. Okay. Right, so next is parallel. So parallel is one of the fastest way to download, and it is actually compatible with major programmers. Alright, so for parallel programming methods, okay, you can update and you can change the codes while running the chip, right? So that is the parallel methods lah, right? So for parallel method, it is require programmer hardware that supports them, okay? And then in system programming is actually a native 2-wire PDI or 3-wire SPI interface, and then it has a quick update in the field and it is easy to use. Okay, so for in-system programming, you are also require a programmer hardware lah that supports in-system programming. And then the last one is JTAG. So sometimes when you program Arduino, the older version of Arduino, they are required some JTAG, we call it interface, where you will see from USB and they will go to external bootloader, and then from there it will goes to the chip, right? So that is the JTAG. Right, so for JTAG, it is actually IEEE 1149.1 compliant interface. Right, you can for JTAG you can program flash, you can program your EEPROM, you can program your fuses, and you can program your log bit. So you can program everything by using JTAG. Okay, so it is on chip debugging, and also it can use to do some boundary scan PCB tests. Right, so if you wanted to do a thorough or a detailed troubleshoot to your chip, you can use JTAG. Right, so next is the pin out for your Atmega 328 pin. Right, so for the first pin, so this is pin number 1. So pin number 1 is actually the reset lah, the reset button. Okay, that you can see in Arduino, it is being connected to pin number 1. Right, so it is used to reset the operation for your microcontroller, for your chip, right? Okay, and then pin number 2 here and pin number 3 here, it is actually the transfer and receive serial. Okay, so in your Arduino, if you can see at the pin 0 and pin 1 for your Arduino, okay, you can see TX and RX. So TX is to transmit, RX is to receive, alright? So as you can see from pin 4, pin 5, so pin 4 and pin 5 is actually the interrupt pin. Okay, and then as you can see from the pin number 6, it is actually the clock, and then pin 7, pin 8 is the VCC and ground lah. VCC is the voltage supply for you, and pin number 8 is the ground. Alright, pin number 9, pin number 10, it is actually a timer. Okay, and pin number 11 is actually a digital input or digital output. Alright, and then pin number 12 here, it is actually also the digital input lah. Digital input here, 12, 13, 14 is the same digital input, 15, 16, 17, 18, 19 is also a digital input. Alright, but for 17 and 18, as you can see here, it is MOSI and we call it MISO. Okay, MOSI and MISO is actually an SPI interface. So that is one type of the connections that your microchip can we call it can support, right? And then SCK is the I2C pins, right? And then you have AVCC is the analog, we call it analog voltage, we call it analog reference voltage. Okay, sorry, AVCC is this analog voltage supply, and then AREF is the analog voltage reference. All right, so if you want your sensors to have different type of reference voltage, you can connect it to this pin. Okay, so next is the ground, and then all the other from 23 until 28 is the analog to digital converter. So it means that it is actually the analog pin on your Arduino. Okay, so that is the pin out of the Arduino. Alright, so this is actually the block diagram of your Atmega 328. Alright, so as you can see, this is the brain of your chip, which is the AVR CPU. Alright, so as you can see here, the flash memory and also the SRAM memory is separated from each other. Okay, so based on this observation, it is obviously that Atmega 328 use Harvard architecture to operate. Right? Okay, so from here, you can see it is being separated. So it has different buses to connect to the CPU. Right? So it is Harvard architecture based chip. Alright? So as you can see here, this is actually just like power supervisions that will supply your VCC and ground. Right? This is just the debug wire, watchdog timer, watchdog oscillator. So this is will use to select the frequency, sampling time, and so on. Right? So this is your EEPROM, which is the we call it the memory which is not being erased after you switch off the chip and so on. And this is actually the peripherals of your CPU. Okay, so as you can see here, you have the timer counter here, you have the analog comparators, analog and digital converter, and it is being connected to the port C, port B, and port D, which is your I/O lah, input output, right? So this is the USART. USART is the basic serial interface that you use for your by using your USB. SPI is the another type of another type of interface, and TWI is also another type of interface. Right? So all of these are being connected by using data bus. Right? So next is the pin out descriptions. Okay, so VCC and GND. Okay, is actually VCC is the digital supply voltage, and GND is the ground lah. Right? So basically for Atmega 328, the supply voltage, it can goes from 2.7 volts to 5.5 volts. Okay, so if your system requires the voltage supply among or which is in this range, you can use the supply directly from your Arduino. But if your system require a higher voltage supply, okay, for example 7 volts, so you cannot connect your system to VCC because it doesn't have enough voltage to power up your device, right? So next pin XTA-L1 and XTA-L2 is actually a connection to oscillator for clock signal generations. Okay, so for XTA-L, it is actually an oscillator to measure the frequency, to measure the, we call it reference time, to measure the timing of your CPU. Alright, so that is the function of XTA-L. Okay, next is the reset. So reset, it is actually used for generation for reset to set it all input output to the initial value. So basically when you press reset button inside Arduino, okay, basically you are pressing the reset button inside your microchip. Okay, so for the main function of the reset button is to make all of the variables, okay, to initial value. Alright, in your input or your output to make it into the initial value or default value lah that you have set in the earlier part of the coding. Right? So next is the AVCC. AVCC is the supply voltage pin for ADC, okay, which is, and also the AREF is actually external analog reference pin for ADC. So as I've been mentioned, if you want your reference voltage for your analog input or analog output to become higher, or to become lower than and then the current reference, which is 5 volts, you can connect your pin to AREF, right? And then port B, port C, and port D. Right? Port B, we have 8 pins. Port C, we have 7 pins. And port D, we also have 8 pins. So all of this port B, port C, and port D is actually an 8-bit bidirectional digital input-output port and can be programmed to serve alternate function. So what does it mean by bidirectional here is that it can also acting as an input, it can also acting as an output. So it is depending on the way that the architecture is being built. Okay, but the microchip is provided a total of 8 plus 7 plus 8 is actually 23 lah. Right, 23 pins which you can program to become input or you can program to become output. Right? Okay, so this is the Atmega 328, we call it a schematic diagram lah. Okay, so this is the system applications, right? As you can see here, so this is the chip, okay, and it is being used to connect to the Arduino, right? So this is the pins, analog pins, and then this is the digital pins, another digital pins, and also the supply. This is the supply, and this is also the digital pin. All right, and then this is RS232 interface to program with the bootloader. Okay, so this is the interface which already we call it connected to the bootloader and so on. And this is the ISP connector. So all of this chip is already connected to external peripherals for you to make it easier for you to program. Right. So next we proceed with the Atmega 328 programming tool. Okay, previously you learned about how to program Atmega 328. Okay, you have parallel programming, you have physical link, and so on, right? And this part is actually what tool you can use to program your Arduino. Okay, so the first one is the Atmel Studio. It is the front end for all AVR tools. So this is free software from Atmel Studio that can enable you to program your microchip directly. Okay, so this is the type of your we call it programming tools. Okay, programming software for you to use lah, right before you use with the real processor. Okay, so next is the starter kits and evaluation boards. So the price is from like 19 USD. Okay, so this example of starter kits and evaluation boards is the Arduino. Okay, so Arduino, this is the chip Atmega, okay, 328P. Right, so this is the Atmega 328, which has been used in the Arduino. So it is being connected to this is the crystal oscillator, this is the power, we call it power regulator, and so on. So all of this has been incorporated for you to enable you to program your Arduino. So you can just connect your USB here, and then you can program by using Arduino IDE. Okay, so this is the example of the evaluation boards. Right, so next is on-chip debuggers and emulators. So this is actually Atmel ICE debugger. So for this, you can do more detail inside your we call it microchip. That is why the price is quite expensive. It comes from 299 USD, right? So for this one, maybe you cannot edit some parts of the inside your microchip, but this one you can emulate, you can do anything that you want inside your microchip. Right? So this is the Atmega 328 programming tool. Right. So inside Atmega 328, you must have instruction set. Okay, for you to instruct, all right, the Atmega 328 chip on what to do. Okay, so we are not going through all of this instruction set because it is a lot. Okay, 1, 2, 3, 4. Okay, we are not going to go one by one because it is impossible for us to go one by one and it is taking a lot of time. Okay, but I can explain to you the first one. Okay, so the arithmetic and logic instructions. So for example, add. So add, it is actually add to registers. So the data that has been saved in two different registers can be added by using mnemonics of add. Okay, so inside the mnemonics of add, all right, you have two operands, which is the variables lah, RD or RR. Okay, RD is being stored in the first registers, RR is being stored in the second registers. Okay, and then if you use add RD, add in the bracket of RD comma RR, it will add RD and RR, and then the new data will be stored inside the RD. Right, so basically the operation is similar with that. Right, and then the flag that is being used, okay, is the Z indicates the 0, C indicates the carry, N indicate the negative, V indicate the two complements overflow, and H is the half carry. So all of these are the related flags reflected to the add mnemonics. Okay, alright, so it only require one clock cycle to operate these things. Okay, for this first mnemonics. Okay, alright, so when we go to the next, okay, as you can see here, alright, so the next example is global interrupt enable. So global interrupt enable, it will store 1 to the operands I here, right? it will store 1 to the flag I here. So flag I here, it indicates the interrupt flag, alright, the global interrupt flag. Okay, so you can refer to the instruction set. So I will share the link of the detail on the instruction set so that you can see what is the definition of Z, C, N, V, I, and so on. Okay, alright, so the instruction set is quite long, alright, so you can go through all of those, okay, later. Right, so next we will learn about Arduino. Okay, so for those for this subject, basically for those who haven't know, we will learn about Arduino throughout all of this subject. Okay, so before we learn detail about Arduino, let's us take a look on the introductions to Arduino. So what is Arduino actually, and where does it come from, and what does it base, right? So Arduino is actually an open source hardware platform based on Atmel AVR 8-bit microcontroller and C++ based IDE. Okay, so in the earlier part of the Arduino, okay, it is actually based on Atmel AVR 8-bit microcontroller. Okay, and you can you can program your Arduino by using C++ language, where inside Arduino IDE. Okay. So based on Atmega 328 for Arduino Uno, it is actually based on Atmega 328, which is 8-bit. Alright, it has a 32K, 6-channel, 10-bit ADC, PWM, I2C, and SPL, and all of the characteristics is already inside the Atmega 328. Right, so the power to Arduino, because the strength of the Arduino, because it had a standard board design, it has a very good wiring language. Okay, the wiring for Arduino is very good. And it is open source. Okay, you don't have to pay if you wanted to get some libraries. If you wanted to get some codings, you don't have to pay, right? Because it provided a very complete fundamental for you. Okay, and then it has a very large community. Okay, the community for Arduino is very wide. So when you search to code something by using Arduino, you can instantly find the resources or the coding that has been shared by some researchers or some programmers. Okay, and the last one, the power of Arduino, because it is inexpensive. Okay, compared to Raspberry Pi, the Arduino is much more cheaper than those other microcontrollers or other evaluation boards, right? So next is the philosophy of Arduino. So the word Arduino can mean 3 things. So when you say Arduino, it can still mean 3 things. So Arduino can be a physical piece of hardware, okay, where you can see the piece of hardware of your Arduino, Arduino Mega, Arduino Uno, and so on. Okay, it can also represent the programming environment. So this is Arduino IDE for those who didn't know, right? Alright, last one is it can represent a community and philosophy. So this is the website of the Arduino forum. So where you can do some discussion, you can ask questions, and you can do anything to interact with the experts and also the programmers and also the developers inside Arduino community. So Arduino, how widely is being used, because if you wanted to know how wide the Arduino has been used, it is very wide because it already have a very big community, right? So Arduino can mean 3 things. Maybe it can symbolize a physical hardware, maybe it can symbolize a programming environment, or maybe it can symbolize a community and philosophy, which is inside the website of Arduino forum. Right. So next I will show you some of the Arduino family. So this is not all right? But this is just some parts of the Arduino family that you can find, right? So this is Arduino Nano 33 IoT. So Arduino Nano is actually one of the smallest Arduino, okay, that you can find. It is very compact, right? You don't have a lot of peripherals, but still you can code by using Arduino Atmel microprocessor, okay? And then this is the Arduino Micro, which I believe a little bit bigger from the Arduino Nano, okay, but still smaller than the others, alright? And this is also used at Mega, okay, Atmel microprocessors to program your macro C. So this is the Arduino Uno that we will use throughout this course. And then this is the Arduino Leonardo. Okay, for Arduino Leonardo, they use ARM processor. I think it is also from Atmel. Okay, and then this is the Arduino Mega, okay, where you can have lots of I/O. Okay, this is the digital pin, which is a lot. This is another digital pin, which is a lot, and this is analog pins, which is also a lot of pins. Okay, so you can do a lot of things inside your Arduino Mega. So if your system require much what you call it, a lot of input, a lot of output, you are recommended to use Arduino Mega. Right, so last one is Arduino Due. So the input and output is similar to the Arduino Mega, but this one use more powerful CPU because it is ARM based. If I'm not mistaken, it is 64-bit CPU. Okay, so this is Arduino Due, right? So as you can see, they have lots of families, right? There are another families that in the Arduino, but still I just wanted to show the most general one lah of the Arduino family. Alright, so that for you can get some exposure on what is the example of Arduino family. Alright, so this is some of the comparison lah in the Arduino family. Alright, as you can see, Arduino Uno, they have the 5-volt system, but for Arduino Fio, Arduino LilyPad, Arduino Pro Micro, and Arduino Due, the system voltage is based on 3.3 volts. Okay, so if your sensors or if your system doesn't require a lot of power, okay, you can use the lower power, for example Arduino Due, because it saves much more power lah compared to the others, right? So the clock speed for Arduino Uno is 16 megahertz and compared with the others, so but Arduino Due is 84 megahertz, right, which is so fast. All right, okay, so next is for digital I/O. As you can see, Arduino Uno only have 15, but Mega and Due it has 54, which has lots of I/Os. Right, similar to the Arduino Uno's analog pins, it only have 6, but Arduino Mega have 16 and Arduino Due have 12. Okay, and then PWM pin. So PWM pin is a pin that usually we use to drive the motor lah. Okay, the motor needs PWM signal for it to drive, right? Okay, the programming interface, for example, it is actually USB via Mega 16U2, and this is USB native. You can directly from the USB via Mega 16U2. At Mega 16U2, if I'm not mistaken, it is a bootloader and it is already incorporated inside your Arduino lah. Okay, so as you can see, the cost of Arduino Uno, okay, we call it the original Arduino Uno is about 29.95 USD, but Arduino Mega is 58 USD, and for Arduino Due is 49 USD. Okay, but I think you can get a cheaper lah Arduino from online shopping and from the stores, right? Okay, so now we will concentrate on the Arduino Uno R3. Okay, so the microcontroller that Arduino Uno use, okay, basically it is actually Atmega 328P, right, where you have learned in the earlier part of the lesson. Okay, so for operating voltage for the Arduino is actually 5 volts. Okay, right, so next is input voltage recommended is 7 to 12 volts. Right, so you can power up your Arduino by 3 ways. The first way, by connecting your USB to this pin, right, and then you can also connect DC power to this pin. Right, another part is you can also connect your power in Vin here. Vin, you supply 7 to 12 volts, and another part you must go to the ground lah of your supply. Okay, you have 3 ways to power up your Arduino. Right, so input voltage limits, it can goes from 6 to 20 volts. So if we call it more than that limit, your voltage regulator here will be burned, right? So for Arduino Uno, it has a total of 14 digital pins, which 6 pins provide PWM output. So how to know the PWM output? You can just see the small line here, curvy line here. So this curvy line indicates the PWM pin, right? So analog input pins, it has a total of 6 here, A0 until A5. DC current per IO pin, it is actually 40 milliamp. DC current for 32 volt pins, this is 50 milliampere. And the flash memory that it has is 32 kilobyte, okay, which is inside the Atmega 328 lah. Okay, from 32 kilobyte, 0.5 kilobyte, it is already used by bootloader. So you can program up until 32 kilobyte of program. Okay, so for static RAM, it has a 2 kilobyte, okay, reflected to the Atmega 328 lah. And then EEPROM, you also have 1 kilobyte, which is reflected to what Atmega 328. SEEM4223 have. Alright, and then the clock speed for your Arduino is 16 megahertz. So as you can see here lah, this crystal oscillator here, this is 16 megahertz clock speed. Alright. Okay, so this is the detailed layout of your Arduino. So you can power up by using USB port, 7 to 12 volts parallel jack, and also the V in here, 3 ways. Okay, and then you can program your Arduino by using the USB B port here. Okay, you connect this one, USB B, and then you connect to the USB A to your laptop, and then you can program by using Arduino IDE. Okay, so this is the ICSP in-circuit serial programming, okay, which you can connect if you wanted to do some serial programming. And this is the I2C protocol, okay, SCL and SDA. So it is, if your sensor requires I2C, right, you can connect to this pin. Right, you have LED here, which is reflected to pin 13. Okay, for pin 13, you have SCK, which is the serial clock. And then you have pin 12 and 11, you have MISO and MOSI. It is actually for SPI interface. SS is the sleep select. Right, and then you have 2 interrupt pins, okay, pin 2 and pin 3. Right, and then you have here TDX and RXD, which is the transfer and receive. Right, and then you also have reset, SCK and MISO here. Okay, so you have an additional SPI interface here. Okay, right, this is the Omega, and then this is the, we call it analog pin, and you also have additional I2C pin here, right, additional. So you have total of 4 I2C, 2 I2C connection that you can connect, and 2 SPI interface that you can use, right. And then this is the input voltage where you can give the input for your system to power your system. This is the ground, this is the output to 3.3 volts. If your system requires 3.3 volt, you can connect to this output. If your system required 5 volts, you can connect to the second output. And then this is the reset button, and then this is the reference voltage lah. If you want your Arduino analog to make it into a different type of analog reference voltage, you can connect to this pin. And this is the pin which is not being connected to anything. Right, okay, so basically this is actually the board layout of your Arduino Uno R3. Okay, so this is actually the schematic diagram of your Arduino lah. So this is your Omega 328. Okay, so this is the it is being connected to the Omega 328 PU. Okay, so this is microprocessor lah, right, and then this is all of the circuits, okay, which are being connected in order for you to operate one Arduino, right? Okay, so next is Omega 328 to Arduino Uno R3 pin out. So this is how the Omega 328 is being mapped to the Arduino. Okay, so for example, PC0 until PC5, it is actually connected to the analog input 0 until analog input 5 lah in your Arduino. So GND here become ground, AREF become the analog reference. Okay, and then VCC here will connect it to the VCC. Alright, PB5, PB4, PB3, PB2, PB1, it is actually digital pin 13 until 9. And then PB0, PD7, PD6, PD5, it is actually from digital pin 8 and digital pin 5. And then these 2 pins is being connected to the crystal oscillators. Alright, as you can see in the Arduino, the shiny things on your Arduino. And then GND will be connected to the ground. VCC will connect it to the VCC. PD4, PD3, PD2, PD1, PD0, it will be connected to digital pin 4 until digital pin 0. And then reset will be connected to the reset button. Okay, so the interface, basically what I can say is very, very direct. Okay, so you can just deduce by using the number of pin or types of pins. Right? So that is how the Arduino Uno R3 has been interfaced to the Arduino. This is how the Omega 328 chip is being mapped to your Arduino Uno. Right. So next, we will talk about Arduino Shield. Right? In order for us to maybe do some real applications, right, you may need to connect to the Arduino Shield. So Arduino Shield, it is actually used to connect the I/O board to extend its functionality. Okay, right? So when you wanted to extend, for example, you wanted to have some Wi-Fi connections, you wanted to have some relay operation, you want it to connect your joystick. Okay, so basically we use Arduino Shield to operate. Do you know why? Because it can make your system to become much more compact, and it is much more neater, and it is easier for you to troubleshoot. Okay, right, so Shields connect to the Arduino input-output board to extend its functionality, and then Shields usually come with the library to ease its usage. So basically when you buy a Shield, usually it comes up with the library lah, because it already have its own architecture and it need to use their own library. Right, so hundreds of shields are available, so you can also make your own shield. Okay, there are a lot of shields available, but sometimes you can also make your own shield by buying the component by yourself, connecting, and designing the PCB and so on. So you can also make it by yourself. Right. So this is the example of the shield. Okay, you have the Ethernet shield if you wanted to connect your Arduino to the Ethernet connections. This is the relay shield. If your system requires some relay application, you can connect your Arduino to the relay shields. So this is the motor shield, where you wanted to connect your Arduino to the motor driver, to the motor. You need to use a motor shield, because motor shield already equipped with the motor driver. Okay, so please be aware that if you wanted to connect your system to the motor, okay, you must first connect it to the motor driver, because you don't want to damage your Arduino. Okay, because the motor have the tendency to give the current, or to give the, we call it the back voltage lah, back voltage or back current. Okay, that can destroy your Arduino. Alright, so next we have LCD shield. If you wanted to display inside LCD, it is recommended for you to connect it to the LCD shields. And if your system requires a touchpad, you can connect to the touchpad shields. If your system requires a smoke detector, you can also connect it to the smoke detector shield. If your system requires a joystick, okay, you can buy a joystick shield and you can operate your joystick from there. And then if your system requires you to send SMS, okay, to send information, you can use GSM shield, right? Another one is the NFC shield, RFD shield, GPS logger. If your system requires GPS, you can use GPS loggers. If your system requires a Wi-Fi connection, you can use ESP8266 Wi-Fi shield. If your system requires Bluetooth, you can use HC05 Bluetooth shields. If your system requires a custom, okay, prototype, you can use a prototyping shield that you can connect your system I/O here. Okay, and then if your system requires a sensor, a lot of sensors, you are recommended to use sensor shield. Right? If your system are require SD card and to incorporate with the wireless module, you can use wireless SD shields. If you want your system to have a CAN bus, you can also connect it to the CAN bus shield. Alright, so from this slide, what I can say is that there are lots of shields that are available in the market now. Okay, so if you have a system, if you have a problem and you wanted to solve it by using Arduino, you can find this shield. Okay, shield will make your life easier, so you don't have to develop the circuits for it. It already incorporated with the circuit, and you can just connect it, all of the circuit all together, to make your system to work well, right? So shield is basically it will easier your life. Alright, so next is the Arduino Uno R3 setting ups. Okay, so you can refer to the hands-on exercise lah from the website of the Arduino. Okay, and then maybe you can start to download and install Arduino IDE inside your laptop. Okay, maybe you can just buy a cheap Arduino board and USB cable. You can try to connect the board inside the install the driver, and then you can launch the Arduino IDE, and then you can open the Blink example, and then you can select the board type, select your serial port, and upload the program and run. So I expected all of you will buy Arduino Uno. Okay, and then we will try to program lah Arduino Uno throughout this course. Okay, so I think that is all for our class today. Alright, so in the next class, what we will learn is we will learn about in detail about Arduino Uno, what are the details inside Arduino Uno, and how to program each and every module inside your Arduino Uno. So I think that is all for our class today. So we will meet again physically next week, inshallah. So I hope that you can attend our class as usual. Okay, alright guys, Assalamualaikum warahmatullahi wabarakatuh, and thank you everyone.